Today the topic of discussion is we will study that how to delete a node from beginning of doubly circular linked list. That is, you have to delete the first node of doubly circular linked list. If we talk that what we have done earlier, that we have seen how to create doubly circular linked list, and in that we have seen a menu program. After that we have seen how to print element of doubly circular linked list, and then we have seen how to insert a node in doubly circular linked list, and we have studied three ways of inserting. That is to insert a node at beginning, to insert a node in middle, that is somewhere other than beginning and to insert a node at end. Now our job is to delete a node from beginning, that is to delete. Now we are seeing the deletion case. So let's start with deletion. First of all, we'll see the menu of main doubly circular linked list. So in function main, we have created a variable ch of data type integer. While one means what? Condition always true. While one means what? Condition always true. Condition is always true. Why condition is always true? Because we have put inside the condition 1. If you put 100, 200, minus 250, anything other than 0 is always true. Now in function, inside the loop, you have various print statement where 1 is representing a create, 2 for print, 3 for insert, 4 is delete, and 5 for exit. And then it's asking enter the choice. My job is to delete a node, so I'll press 4. Ch will have 4, switch will have 4. I'll jump to case 4, and in case 4 we are calling a del function. We are calling a del function. So let's see the del function. So here we have a del function. Now in del itself has a menu. Why? Because whenever you go to a restaurant and you ask for a chicken, so in a chicken you itself have a menu of a chicken. That is, you want a fried chicken, you want a gravy chicken, you want roasted chicken, whatever you want. So in that also you have a menu. So in a similar fashion, del itself has a menu. That is, when you press 1, you can delete a node from beginning. When you press 2, you can delete a node from middle. When you press 3, you can delete a node from end. So what do you want? So suppose my job is to delete a node from beginning, so I'll obviously press 1. Switch will have 1. I'll jump to case 1. In case 1, I'm calling a del back function. So I'm calling this. And if you want to see a doubly circular linked list, currently you can see your doubly circular linked list is somewhere looking like this, where head is pointing a node having value 4 and tail is pointing a node having value 7. So let's start with del back function, that is this function. So here you have a del back function where you have created a pointer temp of data type node 1. What is node 1? I told you many times, when you have created doubly linked list, you have created a structure having name node. There are three part of this structure of a node. One is data. One is data, that is data uh, of a node. Then you have a two pointers, one next and one previous. Next will keep the address of next node, previous will keep the address of previous node. Now you have you created a variable of this structure, and then you have type defined it. So type defining means that I am making node 1 as a representative of this entire structure. So instead of struct node, I'll use node 1. And if you want to get a deep knowledge of this, you can see my first video of create. Fine. Okay, so we have created a pointer of temp of data type node 1, and we have initialized with head. What is head now? See the linked list. So you have a head representing a node 100. Fine. So there is 100, and what you did, you have initialized temp. You have initialized temp with head. So temp will also have 100. So finally temp and head both are pointing to same node. Now you know that this node is going, we are breaking this node, we are deleting this node. When we are deleting this node, so obviously head will change its position. So head will be taken by this node. So what actually is taking place, head will have head next. So the updated value of head will become head next. What is head next? 200. So head will come from this place to this place. That is, this node is now represented as head. Fine. So head is no more here. Fine. Okay. Now two part which is very important, that head previous always keep tail. What is head now? This node. Previous is this, will keep tail. What is tail? Tail is 500. So here it will have 500. The moment it will have 500, this link will come from this place to this place. Fine. So this link will come from this place. Finally, now what happens? And tail next. What is tail next? This will have head. Now we have a new head. Head is 200. So here it will come 200. So this link will not go there. This link will come from here to here. Fine. Okay. And this temp will get isolated. So in screen we'll see deleted element is %d. Deleted element is percentage d, and in place of percentage d will print what? Temp data. What is temp? This node. What is temp data? 4. So in screen we'll see deleted element is equal to 4, and we'll feel very good. Yes, 4 is our first node which is deleted now. And what is free PTR? It's not PTR, it's temp. It's temp. I'm so sorry. What is free temp? Free is a dynamic memory allocation function which free the memory allocated, created by malloc and all. So free will destroy the memory of temp. So temp is representing 100 address, so it will destroy. So the moment I use free temp, it will, this node will get destroyed. And finally, the final structure of linked list would be like this. That is, now head is representing a node having value 5, having address 200. Tail remains same, that is representing a node having value 8 and address 500. Now tail next is having 200, which is current address of 200 head, and head previous is having what? Tail, which is 500. So now the final linked list is absolutely correct.